Hello, everybody. It's a pleasure to receive everybody here. We are starting our new webinar in this session on economic geography, economics of innovation, geography of innovation. And it's a pleasure to receive everybody. We are broadcasting this webinar in the channel of the YouTube of the Institute of Economics of University of Campinas. And the webinar will be available in a few hours or few days in the same channel. Today, we have the opportunity, we have the pleasure to receive Dr. Christopher Esposito. Will give us a lecture on the theme. The title of the webinar will be the Silk Road of Science with Dr. Christopher Esposito. Chris has background in economic geography, and today he is the Osborne postdoctoral fellow at the strategy unit at the UCLA Anderson School of Management, where he's also associated with the Price Center for Entrepreneurship and Innovation. Recently, Chris has been postdoctoral fellow at the Mansueto Institute of Urban Innovation at the University of Chicago, and he received his PhD from the UCLA Department of Geography in June 2021. Chris, it's a pleasure to receive you in our webinar. Thank you for accepting our invitation. Please, the floor is yours. Thank you very much.
And thank you very much for the invitation. It's a real pleasure to be able to share this research with everyone. Let me just first double check. Everyone can see my slides okay? Does that work out properly? I'm going to guess that means yes, that the slides are going through, but tell me if it's not following. So basically, this is a research project that's a collaboration with James Evans at the University of Chicago and Renli Wu, who was visiting at the University of Chicago when I was also there. And what we do in this research project is we basically take note of the current state and dynamics and changes of scientific leadership among countries. So it really is a regional development through innovation story, but it's one that's told at the national level or at the supranational level, meaning like global regions of interest such as the European Union or the United States or China. And we're looking in particular at scientific innovation as opposed to technological innovation by using scientific publication data. Just to give an outline of what I'm going to work through in the talk today. First off, what I'm going to do is start thinking about uneven development across space as a process and use that perspective to think about China's scientific development and how this links into uneven development around the world, but particularly focusing on China. So that'll be the story that we're going to be most keying in on. And what I'm going to do then is use the data that we have on scientific publication output to basically describe the changing hierarchy of leadership in international scientific collaboration. So what we're interested in is when scientists from one country collaborate with scientists from another country, who basically holds the upper hand in that relationship, in that collaborative relationship. That gives us a sense of both power dynamics, but also who's basically benefiting and directing those collaborations more. So it allows us to speak to development and uneven outcomes. In terms of the methods, what we're going to do is we're going to be analyzing every scientific paper that's been published in the last 30 years in collected journals in Microsoft Academic Graph. So this is essentially every journal that you've ever heard of, but really any journal that we would often think to publish and gets archived here. So it's a very large corpus of work that we're able to analyze. And what we do is we use machine learning models to look within the teams of scientists on those papers and make predictions about what that division of labor of those teams looked like. So who were the leaders as opposed to who were the supporting members of those teams? And that lets us get a sense then on which scientists from which countries are leading more as opposed to supporting more from different countries. So as I alluded to, this basically gets us a way to say like which countries hold the upper hand in bilateral scientific collaborative relationships, with holding the upper hand meaning that you're in the position of power, you're the one leading and directing, while the other country you collaborate with or the scientists of the other country are the ones who are supporting the orders or the leadership coming from a different place. To preview the main results, so we're basically looking at these changes in the hierarchy of scientific leadership around the whole world, and our data has the whole world in it. But we in particular focus on the rise of Chinese scientific leadership because that is the most important dynamic we were able to uncover in the data. And to preview the results, what we're going to show is that China is basically slowly but steadily overcoming Western dominance in scientific leadership as a whole. But it's also, while slowly and steadily overcoming Western dominance in scientific leadership, it's also developing a position of scientific leadership in an area of the world that has been up until now relatively neglected by Western scientists. This is essentially these countries that are found in Central Asia, South Asia, and Sub-Saharan Africa. So we call this the Silk Road of science because it links very much to the types of relationships, of development relationships that China is developing in these parts of the world through infrastructure spending as well. So we're trying to draw that analogy between the infrastructure investments and the scientific development investments that they're making. So really what we do is we take this global value chain perspective on international scientific development, right? So I'm here including an image of, a phrase that we're very accustomed to seeing on all the Apple products, where Apple products are often designed by Apple in California, but assembled in China, right? And so this is suggesting a hierarchical relationship between the production that happens, in this case in California, relative to in China, where there's basically leadership and creative work being done in one location and more either manual or standardized work being done in another. These production happening in the two places are linked together to produce an output product. In this case, it's the iPhone, right? And it leads to development in both places, but inherently uneven development. And that's because these tasks that are being performed in these two different places have different kinds of skill contents and then reap different kinds of rewards for the economies in those two places. So we're taking this kind of global value chain perspective on development, on international global development, right? And applying it within the scientific research process by looking at teams of scientists. In particular, what we're going to do is we're going to look within collaborative teams on scientific articles, identify the leaders and identify the supporting members of those teams. And the key thing is that the leaders in science are really the ones who are able to contribute ingenuity and management to their projects. They get to determine the research priorities. So based on where those leaders are from, they get to dictate where we're going to go after problems and issues that are perhaps more relevant for where we are as opposed to where our supporting members are. And they also get to appropriate many of the benefits in terms of the technology rents, returns, wealth from the resulting, in this case, research. Of course, teams also have supporting actors in science. These might be the people involved in data analysis, data construction, or managing a lab. They contribute, of course, labor to the teams. They don't just contribute any type of labor. It's really skilled scientific labor, but it is distinct from the leaders who contribute the kind of creative design of the projects. They are disempowered from the ability to determine the priorities of research, right? Because those are determined by the leaders disproportionately. They appropriate fewer of the benefits, whether those are financial benefits or prestige. And the key thing is that not all knowledge and learning that supporters basically perform in their collaborations in these teams transfers into useful knowledge for performing leadership roles, right? If there was a full crossover of knowledge, then supporters could basically learn to lead through doing supportive tasks. But if they're basically not, if they're learning to basically support very well as opposed to lead, they might get trapped. And at the country level, countries might get trapped in essentially performing the supportive role. We think of this as somewhat like a middle income trap applied now to scientific development, where basically a country can become very good at supporting, but not necessarily make the jump to becoming a scientific leader. So that's the perspective that we're taking in a nutshell. I want to introduce a very simple, stylized conceptual model. I think that the model doesn't really nail everything, but it just gets down a little bit of our thinking. What we basically have here is a three-dimensional space with, on the X and Y axis, imagine different types of scientific tasks. So these could be, for example, leading, writing, designing, or more supportive role tasks, such as performing, conducting, analyzing, replicating, editing. And on the y-axis, imagine that there's something about the value of those tasks being plotted, right? What we have in mind then is that one country might begin by performing certain types of scientific tasks, right? But if it really wants to ramp up scientific knowledge production, it needs to basically be able to enter into other tasks as well that help support these tasks. So we view basically the growth of a given country as being conditional on engaging with other regions that can provide more scientific labor in supportive roles. So imagine that these two countries are basically growing their scientific base, scientific production, basically developing as scientific outputters through collaborations, right? Their growth is conditional on the existence of one another. And out of this comes scientific publication, scientific research. And because the blue country is the one that's in the leadership position, able to determine the priorities of that research, these papers are going to be more relevant to the issues faced by the blue country than, in this case, the red country. Notably, in this case, it would be hard for that red country to displace the blue country as the scientific leader, because all of its growth is conditional on its location in this hierarchical relationship as being a supporter for the blue country, while the blue country is the leader, right? The base there is locked in this relationship that we think theoretically, building on a value chain perspective, might be hard to reverse. So from this perspective, the question then becomes, how can the red country start to become a scientific leader? Well, one of the possibilities is that if the red country engages with another region of the world that's plotted in green, right, they can basically set up their own hierarchical relationship of leadership, where now red is in a leadership position vis-a-vis green, and green is in a supporting relationship vis-a-vis red. So this is now then allowing the red country, in this case, to pursue scientific research that's particularly pertinent to, in this case, the red region or red country. So this is basically how we're viewing scientific development in terms of the types of lock-in effects, middle science or middle income traps that might be there, because we think that the development process is this one that's inherently uneven, because there's an uneven distribution of labor that's spread across space and located in different countries. So this is the framework we take into the study. In terms of data, what we have then is we're going to basically analyze every scientific article that appears in Microsoft Academic Graph. So this is millions of scientific articles. I think in total there's 80 million articles that appear in Microsoft Academic Graph between 1995 and 2021 when the data ends. And what we're going to then restrict that data set to is just the papers that contain collaborations between authors that are found in two what we call global regions. So these global regions could be major countries like the United States and China, but they can also be supranational collections of countries such as the European Union. We'll actually have the European Union plus, because the plus designates that we've bundled Sweden and Norway into our European Union. So we're only going to retain the publications that contain collaborations between two or more between two global regions in the data set that we analyze. This then lets us say when you're collaborating with other countries, who has that leadership position, who has that supporting position. We're also going to restrict the data to just publications in journals with an impact factor greater than 1. This lets us have a basic kind of quality filter on the publications we look at. We'll also relax this filter and start to look at higher impact, for example, journals, and see how the results evolve as we do that. So we now have all of the publications that involve collaborations between two of our global regions, like US, China, China, EU, US, UK, UK, China, all of the regions that we've kept in our data set. And what we do then is that we go into those publications and we identify all of the authors in them. And we predict who are the leaders on those papers and who are the supporting members on those papers, right? And that's going to be a machine learning model that I'll introduce in a following slide. Once we have these predictions, we can basically aggregate them up to countries in these relationships to say, where are the leaders coming from? Where are the supporters coming from? In the analysis, I'm going to first show you full distributions of leadership. So leadership ranges on a spectrum from 0 to 1 for any given author on any given paper. And I'll show you the full distribution of leadership values at first. That's going to be empirically very rich, but what it's going to be hard to do from that full distribution is to draw kind of like very concise conclusions and then explore changes in those conclusions across time. So after showing you the full distributions, we're going to parameterize these distributions into two measurements, and that's going to allow us to study dynamics in those distributions across time and also to forecast future changes in scientific leadership. Then finally, in terms of data, we're going to, at the end, delve into Chinese administrative data. And what this is going to do is it's going to let us see much more what's going on in China's building of its Silk Road of science. In particular, we're going to be able to study the inputs that China is using to construct the Silk Road of science, of scientific engagement with Central Asia, South Asia, Sub-Saharan Africa, and also what the outputs are. Basically, is this development of the Silk Road of science allowing China to mobilize global international resources towards topics, scientific topics of interest that are pertinent to China? So in terms of inputs, we're going to look at how much China is spending on educating foreigners at its own universities. And in terms of outputs, we're going to look at the type of research that China is producing with Silk Road researchers by looking at Chinese language theses that are published in China and what kind of topics they engage with. And we'll also look at publication data to see what kinds of fields Chinese scientists publish in when they collaborate with Silk Road scholars. In terms of, I'm going to be talking a lot then about China's Silk Road of science. This is how we're defining it for the purpose of the study. You can adopt different definitions, but basically the shaded colored regions here, we group into this global mega region that we call the Silk Road of science. And as you can see, it's basically Central Asia, a little bit of South Asia, and Sub-Saharan Africa. You could include or remove some of these countries. I don't think any individual one changes the point too much. That basically this is a series of regions that were relatively not engaged with by Western scientists, and now China is making major economic and scientific investments in these regions. So starting to look at the data, what I'm first giving you here is just an overview of the landscape of global international scientific collaboration. So basically, this is the number of papers produced that involve one or more scientists from any of these region pairs. We've also restricted, and from all ensuing analysis, restricted any publications that include collaborations from scientists in 3 or more regions. That just simplifies the analysis. So for example, if there's a paper with a US, a UK, and a Chinese scholar, all on the same paper, we ignore that for the purpose. We only study these bilateral collaborations. So basically, the key takeaways are that the US, collaborating with the EU, was the main producer of scientific international collaborative publications up until 2017. But in 2017, China-US collaborations surpass US-EU collaborations, and they also have a much faster growth rate towards the end of the data set. We then zoom in, so this little insert box corresponds with this figure here, to look at some of the dynamics of some of the country or region pairs that have fewer collaborations, right? And what we want to focus on is collaborations between China and the Silk Road. This was a very small number of papers being produced as early as late as 2016. But by 2021, the end of our data, there are as many collaborations between China and the Silk Road as there were between Russia and the EU. So this gives us a sense of both the significant share of publications that are produced between Chinese and Silk Road scholars, and also the relatively fast growth rate of those collaborations as well. So the question is for us really, there's a lot of China-US collaboration going, or China is basically engaging collaboration around the world. Is it developing leader positions? If so, where? With what other regions? And if so, how are they doing it? And also finally, why would that matter in terms of the scientific output that they're producing? So to know whether China's developing leadership positions with other countries, we basically look within the author list on papers and make predictions about who are the leaders and who are the supporting members on those papers. To do this, we begin by building a training data set where we're able to identify leaders and supporters with more of a ground truth. To build this training data set, what we do is we go into the contribution statements that are found on 3 very prominent scientific journals. Publications in Science, Nature, and PNAS all contain contribution statements from the authors that list, for example, author A led the project, author B wrote the article, author C collected the data, author D helped and assisted in editing the final document, right? So there'll be these kinds of contribution statements. And what we've done is we've parsed all of those contribution statements. And then based on the authors and what they're listed as providing multiple contributions, we run a clustering algorithm, which identifies 3 distinct clusters. One is shown in red up here, one in deep blue, and one in light blue. Looking at these clusters, what we can see is they're very cleanly grouped into leadership and supporting tasks. For example, the red ones list that so-and-so led the project, or author B wrote the paper, or author C conceived the study, right? We really identify these as leadership tasks because they involve a lot of critical decisions that have to be made. In blue, we have what we call direct supporting roles. These are roles such as, author D collected the data, author F assisted in the study, and so forth. And the key point is that projects in this area involve fewer decision steps than the ones that fall in the lead category. Then in light blue, we have what we call the indirect support roles. These are commenting, discussing, contributing, providing, supporting. These are somewhat of like an assisting role. So what we do then in the training data that comes from those 3 journals is we basically draw a line right here saying that we're going to make a binary classification. There are leaders and there are going to be supporters, right? And so now we identify each author in that training data as being either a leader or supporter based on whether they are showing up in leading or supporting roles in their contribution statements. And then to extend that training, these leadership indicators to the full data set of all the scientific publications, this is 80 million publications in Microsoft Academic Graph, we build a machine learning model that predicts whether a given scientist is a leader or supporter based on all of their individual attributes. So we go in and look at all the scientists and identify all of their prior publications, all of the prior papers that they've written, all of their prior citations that appear in their papers, all of the prior keywords that appear on their papers, and basically build a kitchen sink model that's then spit into a neural network to predict and classify the individual scientists as leaders or supporters. The model achieves a precision of 70% in terms of predicting leaders or supporters in an out-of-sample prediction using the publications in PNAS, Science, and Nature. And then we roll it out to all of the other journals as well. So we now have a value that ranges from 0 to 1 for every scientist on every paper, where 1 indicates a very high likelihood that that individual was a leader on the paper, and 0 indicates a very high likelihood that that individual was a supporter on that paper. So then looking at those scientists and papers for this papers that fall within our data set, these are the ones that have collaborations between 2 or more global regions. This is what the distribution of leaders looks like. So again, the high values of lead probability are the scientists that we have high confidence were leaders on their teams. The low values are scientists that we have high confidence were supporting members on their teams. So you're now looking at about 2 million papers that appear in this distribution. And we've broken them out by different team sizes. So a paper with, for example, 2 authors is plotted here in the blue, but 10 plus authors is plotted here in the red, and all these intermediate sizes as well. What's very obvious is that this distribution is bimodal, meaning it has 2 peaks. Right? There's a peak at these low leadership values representing supporting actors, and there's a peak at these high values representing leaders. So what we'll do is we'll take advantage of this bimodal distribution to say we're going to now identify leaders and supporters using a binary definition, and we're just going to draw a cutoff value. In the main analysis, that cutoff value is going to be at 0.75, where basically everyone with a lead probability of less than 0.75 is going to be tagged as a supporter, and everyone greater than 0.75 will be tagged as a leader. But we can move this threshold around, and we'll show you how that affects the takeaways from our findings. So this is basically the main distribution, right? And the question we have is, when scientists from one region collaborate with scientists from another, which region or country is basically occupying more of these leadership roles, and which country is occupying more of these supportive roles? So we're going to start by looking at the China and the United States, but we also have in some appendix slides analyses for example, European Union, United Kingdom, and we have in our data set also the ability to analyze parts of Latin America. I would love to pull some of those out as well, but I don't have those in the appendix slides. But we can see some of these bilateral relationships as well, and we can come back to that later. So here what we're seeing is the distribution of leadership scores for China-US collaborators, and it's broken out to 2 time periods to show the dynamics. So the first one on the top is 2010 to 2011, so it's 2 years pooled data. The second one is 10 years later, 2010 to 2011. Focusing first on 2010 to 2011, the red line plots the distribution of Chinese scientists that engaged in collaborations with US scientists, right? So it's only scientists that collaborate between these 2 region or country pairs. The blue line is the United States scientists. So what we can see is that there are more Chinese scientists engaged in collaborations with the United States in 2000 to 2011 that were in supporting roles, but more in leadership values coming from the United States, right? Especially at these very high leadership values of about 0.7, 0.8. With these upside down triangles, we plot the share of scientists at any given leadership bin value that came from China. So for example, at a value of 0.25 or 0.3, about 60% of the scientists were coming from China. But at a very high leadership value, such as 0.75, we're finding that about only 25% of those leadership of those scientists were coming from China. So this is a case where basically the leadership relationship, the upper hand in these collaborative relationships, was tilting towards the United States quite strongly in 2010 to 2011. Moving forward in time to 2020, 2021, what we see is that this relationship starts to change a little bit. Basically, the US's lead in terms of leadership has started to shrink. Yes, the US still has more leaders engaged in collaborations with China at these very high leadership scores, such as around 0.8. As you can see, these blue triangles are in blue now. They're below the 50% line. But what we see is that basically China's made major inroads in these middle leadership value scores, right? And these triangles are starting to move up even at the highest values, right? So this suggests quite a bit of catch up in terms of scientific leadership vis-a-vis the United States by China during this time period. We now then look at China and the Silk Road of science. So this is the country of Central Asia, South Asia, and Sub-Saharan Africa, to see if basically they're establishing leadership positions there as well. So looking at now this pair of relationships, what we find is basically China has always enjoyed a position of scientific leadership vis-a-vis the Silk Road, right? With the exception of the very high scores, which are quite noisy, China had more leaders than supporters at all values, right? In 2010, 2011. And by 2020 to 2021, their relationships just basically solidified and grown very robust. At the same time, way more papers are being produced by scientists collaborating between these 2 global regions as well. So China, while it's catching up to the United States in terms of leadership over time, it's always been a scientific leader vis-a-vis the Silk Road, and it's just ramping up the intensity of that relationship now. So these measures, these are what I call the full distributions, because I'm showing you every scientist engaged in these collaborations and all of the different leadership scores. What's nice is it's a lot of empirical richness, but what's hard to do from these figures is it's hard to know exactly, it's hard to summarize it concisely and say, how are these changing over time? So I'm going to now introduce two ways that we measure these distributions. We basically approximate them. The first is what we call the share of leaders. And so for a given country in this bilateral relationship, for example, in China relative to the Silk Road, the share of leaders is simply the percentage of the total number of leaders that are coming from one country as opposed to the other. So in this, it would be the count of the leaders coming from China divided by the count of the leaders coming from China plus the count of the leaders coming from the Silk Road countries, right? That would give us then China's share of leaders vis-a-vis the Silk Road. This gives us like an absolute magnitude of which country contributes more leaders. But you might also say, well, what if China just has a way bigger scientific population? They also have way more supporters. So we'll develop a second measure, which we call the lead premium. And this is to say, to what extent are the scientists from one country biased towards leadership and away from supporters, right? And we're going to basically report both statistics and allow you to basically make an informed assessment about what different stories these tell. So we call the second measure the lead premium, and it's very simply measured. It's the share of leaders that come from one country, as I discussed earlier, minus the share of supporters that come from one country. So we're now introducing this correction for if you have a lot of supporters, we're basically going to punish you then, because we want to know based on this lead premium measure how much your country is biased towards leadership and away from supporters, right? So these two measures capture somewhat different things. If a country has a really high share of leaders but a low lead premium, what it means is that the country is has a lot of leaders but also a lot of supporters. But if a country has a high lead premium but a low share of leaders, it might be what we call like a small but mighty country. Think, for example, Singapore or Switzerland, that have a small number of scientists, but their scientists are very elite. So with these two measures, we're able to plot then the dynamics of the share of leaders and the lead premium across time. That's what we do for China in bilateral collaborations with the United States, the European Union, the United Kingdom, and the Silk Road in these figures. The share of leaders is shown on the left, the lead premium is shown on the right. So in terms of the share of leaders, I'm going to first focus on share of leaders with the United States, and so that's these blue dots, right? And then what we do is we fit a linear fit line between the blue dots for the last 10 years, and that lets us forecast how the share of leaders will evolve into the future if the past predicts the present. Namely, China in 2000, in its bilateral collaborations with the United States, contributed about 25% of the leaders. The United States contributed about 75%. That has changed with a linear relationship with a slope of 1 for the last 10 years. So by 2000, China contributed 35% of the leaders and the United States 65%. Extending this slope into the future gives us a prediction that China will contribute as many leaders as the United States will in the collaborations between US and Chinese scientists. That will hit parity in 2033, right? That year of parity is like a key prediction then on when we expect this relationship to start to change or to hit parity, right, in terms of leadership. With the EU, we find a very similar slope and series of relationships where basically parity is predicted in 2032 in terms of share of leaders. In the UK, we're predicting parity sooner in 2024. And then notably with the Silk Road, right, China already enjoys a large leadership position with Silk Road science. So they're already leading, and that relationship will never invert. It will never hit parity. So the share of leaders is also in part rewarding China for just having a very large scientific population. So our second measure is the lead premium, and that's shown on the right. Here we're basically now also punishing China, if you will, for having many supportive scientists. We again plot these relationships, and in this case, parity is reached when you hit a value of 0, because that's to say that your lead share is equal to your supporter share relative to the other country. In this regard, we predict parity for the United States and China in 2081. So notably, about 50 years after we predict parity in terms of the share of leaders between China and the United States, right? One way to make sense of these two different predictive years, 2033 for leaders, 2081 for lead premium, is that after 2033, the United States relative to China will essentially look small but mighty, right? It will have fewer leaders engaged with China in terms of its leadership, but it will also have fewer supporters. So those who engage with China will be often very likely to be leaders. Basically, small but mighty, we think of it as looking more like Switzerland or more like Singapore, right? In this regard, the values for the EU look quite similar to what we were looking at earlier, with the a couple of years changing. Again, parity is reached with the UK sooner, so the UK doesn't look very strong according to this metric. And parity's already been reached in this regard with Silk Road. So I then alluded to that we can basically look at how the results change when we also use a different threshold where we define leaders. So we used this value of 0.75 and said anybody greater than that's a leader for these figures, and anyone less than that's a leader in the earlier ones. Here, what we do is we say, well, what if we define that threshold of you must be greater this in your lead probability or less than this in your lead probability to be a leader or supporter? What if we move that threshold around? How does that change our year parity predictions? So focusing just on China and the United States, we were basically in this world at 0.75 in the previous analysis. But if we start to get a little bit more lenient with that, what we find is basically we expect China is going to reach parity sooner. I think it only makes sense to consider lead probability thresholds greater than 0.5 to cut off the leaders, because we don't want to identify supporters in this area as leaders. But basically, as we move to a more relaxed definition or threshold of leaders, China reaches earlier on. So this is saying that basically at the very high leadership thresholds is going to take China longer to invert that relationship. We can also then look at how the year parity prediction changes as we look at journals in different impact factor bins. So the higher the impact factor, the more prestigious the journal is, right? The main analysis included every publication in journals with an impact factor greater than 1. But here what we basically find is, as we look at journals in higher impact factors, the year where China hits parity in terms of its lead share with the United States doesn't change very much, right? The lead share moves from 2036 to essentially 2037, 2036 as we move up impact factors. So this is showing that basically China is really growing in its number of leaders that are publishing in high impact journals, right? That's definitely something that's going on in the data, and we're predicting that they're going to hit parity quite soon in terms of the number of scientists in those journals. But when we look at the lead premium, as we look at these very high impact factors, we see that the year parity really pushes back to 2155, and then on to never hitting parity, so infinity. What this is saying is that when China collaborates on papers that are going into high impact journals, they're also having so many supporting members that they're never going to resemble the United States in terms of their distribution. They'll never be as biased towards leadership. The United States will always look small but mighty, if not big and mighty, in terms of publishing in these top journals, based on our forecasting from the last 10 years. We can break this down by different fields of science, right? And so again, we're just focusing on China and the United States. But basically, what we find kind of confirms our expectations. Areas where we knew that China was doing very well in, such as computer science, chemistry, material science, earth and life sciences. Those are the fields where we predict that China's going to hit parity first with the United States. But then in the fields that we don't anticipate China doing as well in, humanities, social sciences, medicine, those are also the ones where we find China is is going to take longer or never will reach parity with the United States. So all of this then spoke to all of this speaks to basically China trying to catch up and in reverse a hierarchical collaborative relationship in science vis-a-vis the scientific West, but most focusing on the United States as the largest scientific producer, and the main headlines that we see about this. But what we're also interested in is whether China is starting to develop scientific collaborations and a hierarchical relationship that it can dominate and lead in with other parts of the world. So what we did is we delved into Chinese administrative data to basically see what they're doing to start to make connections and build up scientific ecosystems in what we call the Silk Road. So again, that's Central Asia, South Asia, and Sub-Saharan Africa. And one of the things that we found is that they are educating a very large number of foreigners at Chinese universities. So here what we're doing is we're plotting the total number of international students that are enrolled at Chinese universities by year and by the region of origin. So you can see that East Asia was and continues to be the largest region of origin. This is many, especially South Korean students going to China. But the Silk Road is now the second largest region, and quite clearly it's the fastest growing one, right? It's the most interesting, I think, story in this figure. So China is educating a very large number of young knowledge-based workers at its universities. And how is it doing that? Well, what we did is we delved more deeply into Chinese administrative data. And what we were able to pick out is how much China is spending on educating foreigners at its universities. It's actually paying tuition for foreigners at its home universities. And also we looked at what the students are working on and publishing in when they come to China from foreign locations. So these lines show the budget for foreigners to study at Chinese-based universities. That's the blue line. The red line is a reference, is how much China is spending to send its students abroad, usually to Western countries to study, such as the United States or the United Kingdom. And what we found is that basically in dollar terms, China spent about $4 billion US in today dollars over the last 10 years to educate foreigners at its home universities. And as we also saw from the previous chart, those foreigners are very likely and increasingly likely to come from these Silk Road nations. So there's a major capital investment to the tune of $4 billion that was spent on educating foreigners at its home universities. We then delved into a database of all of the theses, master's and PhD theses that were published in China, in Chinese language and based, in mainland China. And we then looked at what kinds of topics the students are publishing theses on. And we were most interested to see if they were working on topics that are relevant to China's economic connections to this Silk Road part of the world. And what we found is that there's a major ramp up over this time frame, shown in red and also in this teal color. Red is publications by Chinese nationals on the topic, and teal is publications by foreigners on the topic, of theses that mention the Silk Road in their title, right? So what this shows us is that there's this ramp up of knowledge and scientific production that's dealing with an economic system that China has put into place through a series of capital investments that are aimed in part to generate returns on capital for China, right? So what I really want you to take away from this figure is the first point. China spent billions in US dollars, $4 billion in US dollars over the whole time period to educate foreigners at its universities. And those foreigners are increasingly from the Silk Road. Students at Chinese universities perform research about the Silk Road. And then we see at the very end of the data set, the theses share start to decline. And this is really the uptake of theses that are written about COVID-19. So the pink is COVID-19 related theses, right? So COVID-19 shifted Chinese scientific attention away from Silk Road, right? But the budget for foreigners started to resume growth in 2023, basically as China starts to reopen. So we're wondering if basically we're going to see a return to this period of investment and theses and research interest about the Silk Road. To get a better sense also what other outputs China is getting by developing the Silk Road of science, we looked in the types of fields that China and Silk Road scientists collaborate and publish in. So these are papers from scientific paper publications, and we're now just breaking them down by field. The largest fields are chemistry, material science, earth and life sciences, and that didn't surprise us very much. But what was particularly interesting to us was that humanities and social sciences ranked third in terms of the number of papers, and it had one of the fastest growth rates over the time period. It surprised us that China and Silk Road scientists were collaborating in the humanities and social sciences as much as they did, third ranked of all the fields, because Chinese scientists don't publish very much in the humanities and social sciences in Microsoft Academic Graph Archive publications in the first place. So this was a surprisingly large focus or concentration in that area. So we then parsed the humanities and social sciences to look more narrowly within that to see what subfields they were working in. And we found is basically they're working in economics and business, right? Those are the top two subfields that China is collaborating on with the Silk Road. And as we started to, at this point, there's not too many papers, so we're able to look at what the actual titles and abstracts and subjects of these papers were. And we found is it was really research that's about issues in Silk Road nations that are relevant for Chinese investments in those countries. So, for example, we found business economics papers that were doing cost-benefit analyses about building a new dam using Chinese capital in Nepal or in Pakistan. And we were also finding studies that were looking at how climate change is expected to impact Chinese investments in rail infrastructure in East Asia, where the rail is being used for agriculture, and perhaps the demand for that rail will be influenced by climate change and agricultural output. So basically, we're picking up this series of research that's being co-produced by Chinese and Silk Road scholars that's on topics that are relevant to the Chinese investments in these regions. So let me pull it all together, and then we can move in for question, answer, and discussion time. But basically, the starting question we had is China's supremacy in scientific leadership vis-a-vis the United States, or more broadly, Western scientific leaders such as the European Union and UK, is that imminent? And the first thing we found is that in 2033, we predict that China will have more leaders in collaborations with the United States than the United States will have in collaborations with China, right? And in 2081, we predict that China will be equally biased towards leadership and not supporting roles relative to the United States. So the way to basically read between these two values, these 2-year predictions, is that after 2033, the United States will look relatively small but mighty relative to China in its collaborations with China. And after 2081, if these trends continue through that far out year, it would suggest that China is not only having more leaders, but also being more biased towards leadership than the United States. China's Silk Road of Science, right? We want to understand why are they going in there? How are they building the Silk Road of Science, and what's coming of it? Well, the motivation for this in part is because that these dates for achieving supremacy or a leadership position with Western countries are still relatively far out. A lot can happen between now and then. These trends could break. 2081 in particular is far out. So there's a strong incentive then to try to build leadership positions around the world more swiftly, right? And that's something they were able to do with their Silk Road of Science. And basically, they've established a strong leadership position already in Central Asia and Sub-Saharan Africa. They've done this really by training Silk Road youths, right? So they're using people from the Silk Road, young people that they're training at their universities, and they're basically mixing labor, if you will, from the Silk Road with Chinese capital. So they're making massive expenditures, or they have made massive expenditures to educate foreigners from the Silk Road at their universities. Again, the value is about $4 billion that they spent in this regard. What is the output of this? They're basically now able to perform research that is pertinent to Chinese economic interests, right? So able to deploy international labor now, international scientific labor towards China's own sets of objectives. These objectives might also benefit the countries that are receiving the investment and the training. They probably do, right? But that's, the point is also that it is allowing China to enjoy this kind of sphere of influence and the benefits of being a leader by being engaged in these countries. Policy implications. So we've been reflecting on these developments in large part by the debates that are happening in the United States government in terms of how the United States and China should engage in science and technology relationships, partnerships, restrictions, perhaps, right? I don't know exactly to what extent these discussions of, being picked up and stuff in places like in Brazil. But one of the implications that we thought was quite interesting from the study is that there is a strong sense that the U.S. and China are in a form of competition with one another, and this is a technological, scientific, economic form of competition. It also can, in quite worrying scenarios, lead to also like increasing hostility and even military kind of mobilization. But what we basically think comes out of these findings is that one way that the countries could compete that would actually be quite productive is that they could compete by educating the world, similarly to basically how China is engaging with the Silk Road of science, building the Silk Road of science through these investments, right? And China is doing that in part because it generates major benefits for China in terms of extending its cultural, economic, and scientific sphere of influence around the world. And basically, the United States could respond with a similar strategy. This would be in terms of a specific policy that the United States could, for example, do is an in-kind expenditure of $4 billion, like what China spent on educating foreigners at its own universities. The United States could spend $4 billion to educate foreigners at U.S. universities. And this would basically educate foreigners from other parts of the world, lead to economic development around much of the world, and expand the United States cultural and economic sphere of influence, which has then these major scientific and strategic benefits for the United States. So it's both beneficial for the places that receive those kinds of educational investments, but it's also very much aligned with the strategic interests of the United States as it's trying to understand how to engage with Chinese science now. And that's the final point, basically, that if competing by educating people from around the world in your own institutions and academic, universities, this also has then major benefits for the places that are receiving education, in this case from like leading universities. So that wraps up the entire talk. I'm looking forward to questions, discussions. This is my second time presenting this research. I'm really looking forward to doing it with myself. And also getting a perspective from Brazil, I think would be really cool, because I know that the Brazilian context in this is also quite interesting and very relevant as well. So with that, I pass it off to any questions, please.
Thank you, Chris. Thank you very much for a very interesting and exciting presentation. Congratulations for your huge data research, a lot of data, 80 million articles, international collaboration, very, very interesting. Well, I have some comments. We have two questions on the chat. I'll make my comments, and I can ask you the questions in the chat. Well, first of all, the growth of China in the international scientific landscape is impressive. In fact, I think Chinese research has become chief actors in this scientific landscape, and I think your results not only confirm that impression, but also you present some interesting advances, showing that not only an increasing participation in the scientific landscape, but protagonistic role as leaders in research. I have 3 points, and I will ask 2 questions in the chat. My first point, there is I don't know, is I never seen research results on this, but many people comment that the Chinese researchers is increasing their share in the production of scientific papers, articles, and so on. But most of them, people say, I repeat, I never see empirical data on that. But people say that they publish more, they produce more, but the impact of their papers are not so high as in the average in other countries, United States, UK, Europe researchers. Uh, well, I don't know if I understand that your cut is impact factor uh, one and more, but I don't know if you have some comments for this first point. The
Mhm.
second point is related to the mobility of researchers. We know, if, even because we are in Brazil, we are in Latin America, that United States, Europe, but especially the United States, has, let me say, the power to attract researchers from all around the world to United States or to Europe, but especially to United States, to their research, to the PhD. They not only invite people to American universities, but also they hire high impact researchers from other countries. So
Mhm.
my question is maybe there is a methodological issue that I will talk in my third point. My question is what it's possible to see in your research, in your data, uh, the effects of the mobility. Probably there is
Mhm.
some papers that show mobility of Chinese international researchers, but especially Chinese, to the US, and then they build not only they can collaborate with in research, but they also can build international networks of collaboration. Sometimes this
Mhm.
has uh, important facts on this collaboration. My second question is related to the mobility of researchers. If your data can tell us
Mhm. Mhm.
something about this. My third point is some another one point is kind of mythological issues. I think, as I said, the data research is impressive. Your data and your authors' data research is impressive. Uh, uh, Methodological issues. I will make some small points, small questions. Please be free to answer when you
Mhm.
want. Uh, uh, um, I have maybe I lost the why how you identify researchers by the name or by institution. What
Mhm.
is why my question? For example, you can find a Chinese surname
Mhm.
with affiliation in the
Yep.
China, but sometimes Chinese surname
Mhm.
in U.S. affiliation. So
Mhm.
how you compute in this guy, this researcher
Yeah.
in China
And the
or in the
quick answer for this one is we use the affiliation. So a Chinese
affiliation?
national who is publishing affiliated at a US university will appear as US based publications.
Okay, very interesting. And the second point regarding methodological issues, very your results or knowledge areas are very interesting. But I can advance in this. I don't know if you have data. Did you find different patterns of collaboration in specialized journals, specialized research, or interdisciplinary research? For example, you said about science, about nature, about other interdisciplinary journals, and most of these interdisciplinary journals
Mhm.
has very high impact factors. So it's possible to find different different patterns in these knowledge areas, not only between among the main knowledge areas, but the difference between interdisciplinary research and specialized research, let me say.
Interesting.
Uh, I was, I know it's not on your research, but I think there is a question of funding also. You present some data on funding also. My question is: it's possible to see any pattern of funding, for example, maybe a question. Uh, Funding from Chinese funding agency with international universities for abroad, not Chinese universities can foster this kind of collaboration. I know that your research, you have a lot of work with data, but if you have some data on funding, how is the the effects or the impact of funding? My last methodological question. I don't know. It's a common complaint. Uh, we have this issue in Latin America also in terms of language issues. We have a non English speaking has not the same facility or has more difficulties to access of the in these international journals. Your research can say something about language issues.
Yeah.
Please, Chris, I had a lot of more questions, but I will give you the word for you again, and then we continue to discuss. Please, Chris.
Yeah, so super interesting and great questions and comments. Let me try to rehash my memory and work through as many of them. So with regard to the first one, is like basically, are we picking up a lot of? I was actually low quality publications coming from Chinese scientists, right? Are they basically showing up a lot in our data? That was something that I was very worried about early on. And so what we did is we really tried to bash up the data that, in a way that was going to basically try to remove that out, right? And in the end, I became quite persuaded and actually changed my beliefs a little bit about the quality of a lot of the work being produced by Chinese scientists. And that now I think it's actually a lot, not all, but a lot of it is actually very high quality. And I think that's what we're picking up on. So the first thing is we, for example, have an impact factor filter of 1 or greater, right? That already blows away like the very low stuff, right? But what we found is as we started to move up that filter, right, we still found significant inroads into leadership in science vis-a-vis the United States, right? Even at those higher impact values. And so that was the first thing. The second thing is we only look at publications that involve collaborations between, in this case, China and the United States, right? And that gives already some level of quality filter because the US scientists are usually not engaging in, for example, predatory journal publications. So, and this kind of affirms there's been another recent kind of news headline, I think in Nature, where basically Nature has, I think it's about 80 journals that they've identified, not the ones that they own, but the ones that they index and consider like their high quality ones. And I think that it was in the past year that Chinese scientists surpassed US scientists as leading publishers in the top 80 indexed by Nature journals. So I think that it's really the case that they, I think there's probably still a lot of low quality publications coming out of China. And so it's important like filtering and, we have to be cautious about it, but there's also a lot of high quality stuff as well. And I think that we're picking up really on the high quality stuff that's coming out. The second question was about migration. And that's a super fascinating one. It's one that we did not unpack in the study, and it's one that we think is really relevant. There's an inbuilt relationship between kind of career progression, migration, and shifts from supporter to leader also in science, because usually a young scientist as a student begins as a supporter in a lab, especially in the hard sciences, like in physics and engineering. And then really when they become a PI and like acquire their own funding, they're by default intended to become leaders, right? And in fact, a lot of the Chinese shift from supporter to leader has been fueled by a lot of Chinese nationals being students at US universities, going back to China, getting a professorship and starting their own labs. So this is like a key part of that process that we didn't really unpack the mechanisms, right? And I think that's an important one. And it does raise an interesting question, as basically the Chinese scientists are undergoing a demographic transition. It used to be a very young scientific base. They're now quite mature and older. So while we picked up a very clear linear relationship in leadership over time, right? I think that if you started to think about the demographic transition, you would start to get more of a tailing off, right? And that's something we don't include in our forecasting models. We're just trying to be quite, straightforward about it and, simple in our predictions. But I think that's another model you could, that's another feature you could want to build into this, and something we didn't do. In terms of attracting foreigners to, for example, the United States through the in-migration channel, that's another one that we could do, and we have the Microsoft Academic Graph data is sufficient for that, because you can observe the affiliation every time somebody publishes. So as long as they published in their home country before migrating, you would be able to pick that up. But if, for example, a Brazilian goes to Harvard to be a graduate student and doesn't publish in Brazil beforehand, we wouldn't be able to peg them to Brazil only by surnames or first names, but they could have been born in the United States to a Brazilian family or something as well. So that starts to get a little bit harder. You'll have to remind me now, jog my memory on the third question.
Oh, sorry. The third question is about methodological issues, differences in knowledge areas, language issues, and funding.
Fantastic. Yeah. So the funding, what I should add is the funding data that we have comes from the Chinese Ministry of Education. It does not come from Microsoft Academic Graph and cannot be linked to publications. So we are able to look at basically funding. It's really scholarship money that we're looking at, as opposed to grant money. And so by scholarship money, it's funding for students to study in China as opposed to pursue specific research. Almost certainly funding is linked to leadership, and the ability to fund projects is linked to leadership. It's not something we've done. There's a lab that is trying to build out funding data, but our sense is that it might be a little bit hard to harmonize funding data across countries. So it's something that we're kind of aware of and thinking about, but it might take a little bit more time before we can really unpack that story. But I agree, it's an important one.
Okay. Chris, do you have more time for two questions?
Yeah, absolutely. It's great.
Yeah. We have two very interesting questions from the chat at the YouTube. One from Caio Fernandes and the other one from Luis Roberto Moraes. First question, we are now trying to put your research in our reality here in Brazil and Latin America. Can you tell your research or data can tell anything about collaboration between Chinese and Latin American countries? We have here in Brazil some universities. We have here in the University of Campinas and then an initiative with the name is Confucius Institute, with Chinese, and has some programs together with some Chinese universities, and the others in the BRICS initiative Brazil, Russia, India, China, and South Africa. And the first question is, do you have some your data can show share the participation of Brazilian university and Brazilian research, even in understanding that Latin America in general and Brazil including we have a very low important role in the scientific landscape. But there are some policies here in Brazil, in other countries like Chile and Mexico, to strengthen the scientific collaboration with the other countries, not only with developing countries, especially US and Europe, but also Chinese. Your data can say something for us.
The answer is that we have the ability, and we need to go into that because we haven't done it currently. So it's really negligence on our end because it's a really important part of the story, right? And also to some extent, I know that China's making major investments in Latin American countries now too, similar to what the investments it's making in parts of Central Asia, for example. We haven't actually gone into the data in this regard because we've just been we went quickly to this. But that's something we have the ability to do, and I think that we should. So, in fact, once we run those analyses, I can send them your way, and we'll be able to look at them. So I think we can produce them. Yeah.
Okay. If you need some partner, please, we are available for any scientific collaboration, Chris. Well, Chris, we are running out of time. I don't know if you want to make final comments, final remarks of your presentation.
Well, I think that it's been really a joy to be able to share my research with Unicamp. And if anybody has any other questions about the project or anything, feel free to email me. I think that if my last slide is up, that has my email address. So it's my first last name at anderson.ucla.edu. And I'd be happy to, continue the conversation there.
Okay. Chris, thank you very much. I want to thank everybody that is in our live broadcast. And this lecture will be available in a few days, I think, in the YouTube channel of the Institute of Economics of the University of Campinas. Thank you, everybody. Thank you, Chris, very much. It's a pleasure to receive you online. I hope next time we can meet ourselves and invite you to come to Brazil and to interact more proximity close to us. Thank you very much, Chris.
No, thank you for having me.